Hey guys, thanks for tuning in to another video on ForgottenWeapons.com. I'm Ian McCollum, and today we have a really cool opportunity to take a look at a seriously unusual and really interesting firearm. Now, this started off being called the Neopup. It was designed by a South African gentleman by the name of Tony Neophytou, and the idea here is to do something a little bit different. This is a 20 millimeter handheld semi-automatic grenade launcher. Now it uses a proprietary 20 by 42 millimeter cartridge, and this has a muzzle velocity of about 310 meters per second, which is about 1,000 feet per second. Now, the reason this is relevant is this is substantially higher than, for example, 40 millimeter grenades. This is the purpose of this. The things that are similar to it on the market are things like the Korean K11, and the US XM25. However, what's cool about this one is simplicity, and it just works. It doesn't have a lot of weird things going on. So if you look at, for example, the XM25, that is a 25 millimeter semi-automatic grenade launcher, very similar in basic concept, basic purpose. However, it uses a programmable fuse that's intended to detonate at a specific laser designated range. So the way that thing works is you have a big optical unit, computerized unit, and you put the sight on target and laze the target, and that gives you a range of 287 meters. And then you hit a button, and that information is sent into the warhead of the cartridge. Then it readjusts your reticle to give you the correct holdover. You fire, and the cartridge, there's a bit of circuitry in the cartridge that keeps track of how many times it's revolved, and detonates it at exactly 287 meters. This sounds fantastic on paper. The downsides of this system are, well, first off, it's all battery powered. It has a very complex computerized optic on it. You have to actually laser designate targets in order for this whole thing to work. And that's more complicated in real life than a lot of people realize. If you've ever gone out and just even used a laser rangefinder to try and figure out how far you are from a target at the range, once you get beyond like 100 meters or 200 meters, it's a little tricky to make sure that the laser's actually on what you want and to make sure it's on the right thing and hit the button at the right moment. All of that's like a whole second aiming and firing process built into the XM25 before you can actually shoot it. And then on top of that, it has a proprietary 25 millimeter cartridge that's still under development. Now, compare that to this. So I said this was called the Neopup. It's now called the Inkunzi PAW, or Inkunzi PAW, manufactured by PMP Denel Land Systems in South Africa. It uses a totally standard 20 millimeter projectile, meaning this is the same projectile that's in things like the US 20 millimeter Vulcan. The technology for the cartridges has existed for a long time. It's existing technology. It's cheap ammunition compared to something like the $1,000 per cartridge XM25 rounds. You have a basic set of cartridges. You have high explosive, you have semi-AP high explosive, you have armor piercing, tracer, and a couple practice rounds. And this, it's not trying to detonate the cartridge in a smart way. It just detonates like a 20 millimeter HE detonates. Means it's basically, depending on what kind of fuse you use, it's basically going to go through a little bit of material and then explode. And this is ideal for military applications like shooting through doors, shooting through windows, shooting through light walls of buildings, shooting through light-skinned vehicles. For example, an ideal application of this in the real world are those countries in the Middle East that are dealing with things like suicide car bombers, where what if you have 2 or 3 of those approaching at the same time? Something like a 30 caliber machine gun has to spend a substantial amount of time on target to effectively neutralize a vehicle because you've got little small projectiles and they only disable what they actually hit. So you have to hit the driver or hit something really critical to disable the engine. Well, alternatively, if you had an area effect weapon like a 20 millimeter HE projectile, 1 or 2 rounds are going to pretty much take care of anything like a light-skinned car, or certainly all the people inside it. So this really gives the opportunity for a portable and easily used and rapid fire area effect weapon. It's really an interesting concept. So what's unique about this is, of course, the layout. If you look on this side, we have a pistol grip on the side. This is like a semi-bullpup rifle. The closest thing to compare it to would probably be the FG42, because, and the reason for this unique grip on the side here is to shorten the length of the overall gun. So by not having to put the grip on the bottom and make space for the firing mechanism with the grip and everything else going on there, you put it on the side, out of the way, and then you have a relatively short barrel. This is about a 14-inch barrel. I think it's 335 millimeters. And that's all that's necessary because this is a very heavy projectile with a relatively low muzzle velocity. So I'm sorry, short barrel. You have a receiver unit here, and the whole receiver unit actually reciprocates into the buttstock like in FG42. And that is a critically important component of recoil reduction for this gun, because this is really kicking out a big cartridge, or a big projectile. Now, a couple other things to point out. A lot of people would look at this and say, what's the advantage of this over, say, a 40 millimeter grenade, like a Mark 19 automatic grenade launcher or an underbarrel 40 millimeter? Well, there are two. The first is this is semi-automatic, so compared to something like an underslung single-shot grenade launcher, this gives you 6 rounds of repeat rapid firepower, which is definitely relevant, especially if you don't hit with your first shot. You can then follow up with a quick second shot, third, fourth, fifth, sixth. And then this has a far flatter ballistic trajectory than a 40 millimeter grenade. And that means a couple of things. First off, it means you don't have to estimate your range as precisely, because you're going to have a lot less drop, like tremendously less drop than a 40 millimeter grenade at pretty much any range. It also means the time of flight is a lot faster. So if you are leading a moving target at extended range, 400 meters, with a 40 millimeter grenade, you're talking several seconds of flight time, and you really actually have to consider leading that target. With something like this that's moving 50 to 100% the speed, 50 to 100% faster than a 40 millimeter grenade, depending on type, there's a lot less of that you have to take into consideration. And this basically meets the same benefit as having an explosive round in the first place, which is you have a huge margin of error. You don't have to hit a target with this, you have to hit near a target with this. And that's a whole different ballgame than a rifle or a machine gun. So I have blathered on about this enough. We need to actually put a couple of rounds downrange. Uses a 6-round drum magazine. Got the bolt locked open here. Lock that in place. I am going to look like a dork wearing sunglasses at an indoor shooting range because these are my ballistic shooting glasses and I didn't think to bring clear ones. So let's put 6 rounds downrange. Alrighty, so you've seen it shooting now. Now let's take a look at how this thing actually works, because mechanically this is really cool. This is actually an inertially operated gun, kind of like a Sjogren or a Benelli shotgun. The very first versions of this were gas operated. In fact, actually, Neophytou originally came up with, he decided to do the inertial system and then was tinkering with it and decided, well, gas operation will be better. That'll allow me to have a lot of flexibility with the gas port size and placement and get the thing set up so it makes sure it runs right as a prototype. And then eventually he came back around to the inertial system being cleaner and simpler and easier, and it's a really elegant operating system. So let's start with basic field stripping and disassembly, which is going to involve taking the stock assembly off. All right, actually, before I do that, I should point out that this is currently in its stowed position. So there's a little latch on the bottom here, right here. This is your stowage latch, and this allows you to actually compress the recoil system and lock it in place. That has a couple of purposes. First off, it makes the gun a little bit more compact, which is nice, especially if you are in an APC or in a helicopter. And secondly, it acts as a safety, because with the thing compressed, you can still operate the bolt, but the trigger doesn't work at all, can't possibly work, and you'll see why when we take it apart. So this acts as a really effective transit safety. For example, let's say you have a squad of guys in a helicopter deploying somewhere, leave the gun compressed like this, and it can be chambered, loaded, hot, but completely safe until you get out of the helicopter, hit the button there, and it opened back up, and now it's ready to actually use. Now that we've seen that, field stripping is really quick and simple. This is our stowage latch. This is the disassembly catch. So we just push that on, and that separates the action from the grip and stock assembly. I suppose I should pull the magazine first. So the magazine catch here is interesting. The magazine is held in just by a front and a rear lug, and so this is a pretty typical magazine catch, where when I lift this, that lug lifts up and allows the magazine to come out. What's interesting here is that this lever is pointed directly forward, and that's for good reason. Originally, on the early versions, this thing was pointed up, kind of like you would expect with a typical firearm, and the problem was the recoil, actually, between the recoil and the inertia of the lever here, caused the lever to slip out of position when firing, and occasionally it would drop the magazine. By having the lever directly in line with the recoil, that doesn't happen anymore. So that's how the mag catch sits. The magazine itself is a 6-round drum-type magazine. Sort of a drum. It's got a single spindle, so you get one revolution of cartridges in there. And this is for good reason. They experimented with box magazines for these guns, and the problem is the cartridges in the bottom tend to get jostled out of position, again, under recoil. So having a spindle here that's able to put better pressure on the cartridges and keep them in alignment. It's interesting to note that the front plate of this magazine actually has to be made of some pretty sturdy material because, again, recoil being one of the primary characteristics of this weapon, the cartridges would tend to move forward when under recoil when firing, and with thin metal on the front of the magazine, you actually ended up with dented. You can see indentations where the cartridges had rammed into that front plate. So that's a pretty heavy-duty magazine in order to run. Moving on disassembly, the next thing we're going to do is take out the recoil spring. It's held in place just by a simple plug right here. Now, the current production versions of these have a fully captive recoil spring. This one is an early sort of prototype gun, and its recoil spring is not captive, which is a little more of a pain in the butt to deal with. But there's our recoil spring. Then we can pull the bolt assembly out by using the charging handle here. Pull that, pop that all the way back, and then the bolt assembly just lifts out like so. And that right there is a field-stripped Inkunzi PAW. Now, to me, one of the most interesting aspects to this is the actual operating system. So this has what looks like a gas piston. And of course, I mentioned that on the very first prototypes, these were gas-operated guns, and this was a gas piston. On the inertial, the redesign to make this an inertial operation, this is very much like the guide, the charging handle guide on an HK-G3. That's basically what it does. The charging handle pushes on this, and this just pushes on the rest of the bolt carrier. It has a 2-lug rotating bolt to lock, and you may be asking, what causes that to lock? Well, what happens when you fire is that due to Newton's laws with inertia, the bolt carrier here wants to stay in place while the whole gun starts to recoil backwards. As it does, there's a big spring underneath this semicircular part. In fact, there's actually 2 springs, and they're underneath this cover plate on the back. The top of the receiver hits this, and because this is tending to stay in place and the receiver is moving back from recoil, that actually compresses these 2 really heavy springs through this part. I mean, they're heavy enough, I can't move those at all by hand. As soon as this then starts to move, as soon as the inertial effect kind of wears off, the springs in here decompress, and this pushes back against the receiver and throws the bolt carrier back with enough velocity to cycle the whole system, to eject the round and then load a new one. It's a really cool, simple system. Now, if we look on the receiver, there are a couple other things to point out. One of them is, of course, these 2 big pistons. This is the hydraulic recoil dampening mechanism. This is what compresses to, yeah, I can just get it in a little bit there. That's what gives the resistance to this recoiling into the stock assembly. We have a fire control group in here. that is very much inspired by the AK. It's a pretty simple system. The most unusual part is that instead of having a trigger on the bottom, of course, the trigger's on the side of the gun. And we can actually see that right here. This right here is the trigger. And when this is pushed in laterally, it pushes this out of the way and releases the hammer. So if I go back to the grip assembly here, I have a trigger right there. And when I push the trigger, it pushes a lever out right here. That pushes inward into the side of the actual receiver, and that releases the hammer and fires the gun. This is why when the gun is in stowage mode, it can't fire, because when it's in stowage, this button, this lever, is not lined up with the actual fire mechanism here. So there's a safety lever on the left side of the gun, obviously fire and safe. Despite this being an AK-derived fire control group, you can actually put it on safe and still operate, cycle the action, unlike an AK. So that's kind of a cool little feature. I should have pointed out the markings here. There's not a whole lot. This is PAW, personal assault weapon, 20x42B, B for belted. We'll take a look at the cartridges in a moment. And it's made by Denel in South Africa. Now, here's another really cool physics lesson from this gun. There's actually a stack of basically compression buffer washers inside this housing in the front of the magazine. And that's for a really interesting reason. So, when they were doing the original testing of this, you have a 6-round magazine that locks in here. And what Neophytou found was that the actual point of impact changed substantially between the first shot and the last shot. And this wasn't a matter of like firing in full auto and having it climb. This was a matter of in a rested, on a bench, held firmly in place, the gun would hit substantially differently in elevation when the mag was full versus when the mag was empty. And the reason was that there is a substantial amount of weight in this thing. And because the gun is recoiling, the gun was actually recoiling while the projectile was still in the barrel. And it was actually changing the characteristics of how long the bolt took to cycle, depending on how many rounds were in the magazine, because those cartridges are so heavy. This is an effect that does impact like rifles. However, because the comparative mass of a rifle bullet to the whole rifle is so much smaller than the mass of one of these 20mm shells to this gun, it's an irrelevant thing in a rifle. But what they found is by adding buffers to the magazine, this little buffer right here is able to actually compress just slightly upon firing, and that allows the magazine to effectively slide slightly forward, which gives it enough time for the projectile to clear the barrel before this has an impact on the gun's recoiling physics. So hopefully that made some sense. But that's another interesting element. One of those things that you only find out through experiment and trial and designing things like this. Going back to a slightly more mundane aspect of the gun, we have a charging handle up here. This simply impinges on basically the charging handle tube of the bolt carrier, and it snaps into place in the front. So in order to cycle it, you have to pull it out like that, and then you can move it back. Locks in place. It's not reciprocating, of course. And then it locks open kind of like an HK, except it locks down instead of locking up. And there are a couple reasons for that. One of them is to ensure that it doesn't interfere with any optic mounted on the top of the gun. And the other handy thing is when it's locked in place like this, it's actually accessible to the thumb from pretty much a firing grip. So you can have it locked open, pop it up with your thumb, and the spring will then close it. It's the equivalent of the HK slap, except you don't have to take your hand off of the handguard to do it. So as for ammunition, here's a selection. These are all dummy cartridges, but this is the range of ammunition for the gun. The blue one, of course, is a practice round, just a dummy. Although I'll tell you what, these things actually have a significant terminal effect, because in order to match the ballistics of an actual HE round, the interior core of this is hollow. On these guys, the inside, it's I think a 4mm steel wall filled with high explosive. On this, it's just empty in the center, and that acts kind of like a gigantic hollow point with a practice round when it hits something solid. Anyway, that's the practice. this is the armor piercing, but this is really, I don't think they even make this as a production item for this cartridge because, well, 310 meters per second is a great velocity for explosive. It's not really all that useful for AP. I think they told me this penetrates something like 6 millimeters of armor plate, which is pretty insignificant. If you want AP, don't use this gun. So that's there. What this does point out, though, is these are standard 20 millimeter projectiles. This isn't a proprietary custom sort of thing, and that means they're actually really inexpensive and affordable from a military perspective. So we then have two others. This is probably the main thing that would be used with this gun. This is HEI, high explosive incendiary, and then the one with the black tip is semi-armor piercing HEI. So it's got a little bit of a tungsten penetrator core, and apparently this basically does just as well for armor piercing as a true AP warhead because of muzzle velocity. So this is kind of your general, in normal terms, this would be a general purpose round. For the Neopup, the Inkunzi, I think honestly the HEI is the best round to go for. It's interesting shooting this thing. With a machine gun, you're trying to control it and put repeated multiple hits on target and fight the gun. This, you're not worried about. This thing does its job when it gets there, and it doesn't matter how long it takes to get there, so to speak. All right, so one last thing to take a look at now that I've got the gun reassembled is the actual optics and sighting system. So this is set up with, right now, an EOTech, but I think this is actually really well suited to a red dot. Certainly you don't want a magnified optic on it because of eye relief issues, and with the recoil of this, magnified optic would just pop you in the eye every single time. So instead, the red dot allows quick target acquisition, quick movement. However, the thing that a red dot doesn't do well on a gun like this is account for drop. And this has an effective range of like 1,000 meters for area effect targets and something like 600 for point targets if you're shooting at a vehicle or something like that. So you need a way to accommodate for the drop of something that is, while a very fast 20 millimeter, it's very slow by rifle bullet standards. So it's going to have a fairly substantial drop by rifle standards. And the way they did that is by building the BDC into the optic space. So here on the back, we have this big, obvious, and easy to use knob that starts at 100 meters and rotates up to 1,000. So one full revolution gives you your full effective range. Now, this is enough elevation that you can't do it just with an EOTech reticle. However, it's only about 11 degrees. So looking at it from the side, you can see the whole range of travel. Not all that much. That's not a 40 millimeter grenade launcher sort of, aim at a 30-degree angle up. But it is enough that you want to build that into the optics mount instead of trying to have it in a reticle.